So, okay, let's do the derivative of question 3, okay? Now, first things first, are you happy? We're going to have to rewrite this because we start seeing square roots going on. As soon as you start seeing roots, you need to rewrite. So, we get natural log of sine of x squared, all raised to the power of, yeah, good, all raised to the power of a half, all right? Okay, and then we just apply the Altiini rule, the chain rule, okay? So, we bring the power down to become a half. Lots of, and we reduce the power down by 1, okay? And we leave that inside bit alone. So we just literally just copy that across. Like so. Then we multiply by the derivative of the bit we left alone. So we work our way gradually inwards. So what's the derivative of a log?
1 over.
Yeah, good. So it's going to be the derivative of log of anything is 1 over, leave that thing alone, okay? So sine of x squared. See, that's we're gradually working our way inwards. Okay. So we've dealt with the derivative of the log. Now we need to deal with the derivative of the sine. So what's the derivative of sine?
Cosine x over 2, x power of 2.
Good. Leave the inside function alone. Then we multiply by the derivative of the x squared.
2x.
2x. Spot on. And then we've got nothing left to differentiate. Make sense? You can go back and tidy this up slightly if you wanted to. For example, I see a half times a 2. That's just 1. Okay. I guess this thing, raised to the power of negative half, just means 1 over the square root of that thing. Okay, so I've got 1 over the square root of this thing. So 1 over the square root of this thing, natural log of sine of x squared. Okay, times by 1 over sine of x squared. Okay, times by the cos of x squared, times by x, because of course the 2 and the half is cancelled. Okay, and then just because I want to write it as one big fraction, okay, multiply these together, go together like this. So you get x, lots of the cosine of x squared, literally just multiply those together, and then effectively on the numerator, just multiply those together. So I get sine of x squared multiplied by the square root of the natural log of sine of x squared. If you wanted to tidy it up. If you want to. It's the same thing. It's the same thing. It's not that difficult. It's just multiplying things together. Yeah? Should we go through question 4 as well? Yeah, go on then. I'm feeling generous. All right, can somebody read it out for me? F of x equals? Okay, I'll do it myself. E to the power of cos of natural log of x cubed minus 6x. Is that right? Yes? Okay, fine. So here we go. We just do the derivative bit. Okay? So to find the derivative, we just do the Altiini rule. So we have, well, the outside function is e to the power of something. We leave that alone. Okay? Derivative of e to the power of something is e to the power of something. So it's going to be e to the power of cos of natural log of x cubed minus 6x. Okay? Then we multiply by the derivative of the inner functions. So then we look at this bit, the power. That's my inside function. What's the derivative of cos? Okay, so I get negative sine. I'm going to put that in a bracket to make sure I don't confuse the negative times with it's just subtract. So I get sine of, leave the inside function alone, ln of x cubed minus 6x. Okay? Yep. Then I multiply by the derivative of the inside function again. What's the derivative of log? Good. So I get 1 over, leave the inside function alone. Then I multiply by the derivative of the inside function, which is minus 6. Okay. Then I could tidy that up a little bit, which would give me, well, I guess it becomes all negative because there's a negative hiding in there. And I get, right, let's have a look. 3x cubed minus 6 times by sine of natural log of x cubed minus 6x times by e to the power of, oh god, cos ln x cubed minus 6x, all divided by x cubed minus 6, x. Yeah. There you go. Good question. If it says simplify, then you have to do that. If it says find the derivative in its simplest form, then it does that. I won't be mean. Okay. If you want to leave it like that, that is fine. Okay.